Okay, so hello, Mark. Welcome to Lenio Labs again, because it's the second time you're here, and thanks for your time. Today, we would like to know a little bit more about your professional experience during your career, because you have one of those amazing CVs that everybody would dream about. And well, also this conversation is especially relevant these days with ChatGPT being so in the news, so in mouth of everyone. And we would love to understand a little bit more about what it is, because you have very deep knowledge about these kind of models. So understanding your perspective on all of this would be super interesting. So getting right into it, my first question, my first ask for you is, okay, can you tell us a little bit on your career? Because you started in the academic field with Harvard and Stanford, if I'm correct, and afterwards you moved to the industry. Can you tell us a little bit about how did your professional life go on that from that perspective?
Definitely, yeah. Thank you very much for having me. It's really a pleasure to be here. I've been very impressed with all of you that I've interacted with. It's a great company. Okay,
Thank you very
so
much.
yeah, yeah. So I've always been interested, and probably a lot of you will relate to this, being engineers. I've always been interested in things, so like Legos and electronics and remote control cars, and taking things apart. And so one sort of interested in things, and then another sort of animating those things. Like I always, envisioned my little car had a personality in it, or or I stuffed animals and things. So I think that two of those really influenced what I was interested in. But my parents were an attorney and a psychologist, and they didn't. And I kind of grew up in the, I don't know if you guys remember the Revenge of the Nerds movie or something, where it's sort of, it was really frowned upon to be an engineer. And not that my parents ever did that, but just their example was not engineering. So I made a conscious decision, like early in high school, to avoid, like to not play with any of that electronic stuff, and just, really try to focus on other things. And that kind of, resistance that carried over into undergrad at Stanford, where upon somebody's advice, they said, take a computer science class, early if you want to, because it's a hard major and, it'll take a lot of time. So I started the course, and the first, Saturday, I worked on the first programming assignment, and it just took me all day long. But, you guys know, you lose yourself in it. So, all of a sudden I started it, and I looked up, and it's the end of the day, and it's dark outside. And it was wonderful. I enjoyed it so much. But I looked outside, and my friends were, interacting and playing, and I still had this other thought of, I can't be an engineer. So I dropped out of that class, and picked up others, and was trying to be a philosophy major and whatever. And that carried on for maybe 3 years. But it wasn't until my senior year, in the dot-com boom, so this is like 99,
Yep. Yep.
that I took a break with my brother. Had this idea of sort of some, I don't know, a real estate website. And I started looking into the code, like how one would code a website. And I thought I could do that. So I, kind of picked up some books, and, just kind of taught myself some basic coding, and then just really started loving it. So my senior year, I transitioned to computer science and took like a ton of courses at the same time, loved it. And really started falling in love with it. And then, my focus started turning more to AI, because that's, what I had been motivated with. I like, I like things to be simple. I like the smallest code possible that can do the most, most powerful thing.
Absolutely. Efficiency.
Right. And and so that naturally goes into AI. After undergrad, I worked at Lockheed Martin. It's like a big defense contractor.
Yep.
In the US, and in a research lab there, doing kind of AI things. Then I went back to Stanford for a master's, and there, like, my advisor was Andrew Ng, who's one of the big names, and Peter Abeel, was a grad student at the time. He's a big name in sort of robotics at UC Berkeley.
Yep.
There. So I really got to interact with them. And then I went to Harvard, and my focus has always been on kind of that. It's now called AGI, artificial general intelligence.
Yep.
So the idea of an agent that can do a number of can basically learn to do anything. And I really, focus on like trying to make it something that could be helpful for the individual. But also, and to be helpful for the individual, you have to learn, what they want you to do. So it often takes the form of interaction, like, so the research was a lot of that, like how do you learn from a human? And then after my PhD at Harvard, working on that, the whole focus was just how am I going to support this research? And I think I'm still struggling with that a bit, although I found something good. Iago knows this very well because we talk about it all the time. But so I spent a long time. Some of the ideas I've had is, I'll start a startup, make a ton of money on that startup, and then that'll fund my research. So I've done a bunch of startups, like tractor steering companies. So a lot of stuff in agriculture. I happen to live in an area where that goes on, but just a lot of nutty ideas. All the products worked, but I don't know. Maybe I didn't have the grit to really stay with it because my interest was always in this AI. Then I joined.
Let me interrupt you there for a second, Mark, because there's a couple of questions really interesting So we all start as developers when we do computer science. We start with a programming language. I don't know which one you started, but for example, for me, the first one was Python and Java. And there is a jump between the traditional developer, like most of us are, and moving to AI. How did transition happen? What took your attention? What sparked that curiosity out of you?
Well, I think so. And I think this is one of the things that we take pride in, and you guys probably did it in college or in university as well, was that they didn't really teach programming languages. It's just like the assumption is you'll just learn that on your own.
Yes.
I mean, there were certain concepts about object-oriented and maybe
exactly
how to do that, but the specifics of the languages, they really expected you to pick that up on your own. I don't really know. I think, I guess I was always interested in what one could do with it rather than, I don't know. So I didn't ever really
taking
focus on
to the limit.
Yeah,
taking to the limit. Actually, I had in my students year, I had a teacher that started to teach us how the perceptron, multi-layer perceptron. That was a super interesting class, and I remember that that was my first touch base with AI, and at that time was mostly statistics. I'm not an expert at all in in AI. So did you have something like that on your let's say learning years, or there were specific classes about AI where you studied?
Yeah, there definitely were. There were intro classes. It wasn't all machine learning. Machine learning was just machine learning dominates AI, but that wasn't the case. So I don't even remember what it was. I think it was called a knowledge system or something. And I did have this did kind of get me excited. This is a little bit later, but you would program in like concepts like all men are mortal kind of thing, and then facts into it, and then you program the reasoning system, but all of a sudden you could ask a question and it would answer something, and you couldn't imagine how it knew the answer to that, even though
black boxes.
So I had something like that. I mean, now that seems pretty trivial and not very inspiring, but at the time it was it felt really powerful.
And another question, during your thesis and your master's degree was all about AI, about general artificial intelligence. Am I correct?
Yep, that's right. Yeah, that's right. Machine learning
and these mentors that you had, they were focused on these topics, or they were not focused on narrower topics? Because artificial intelligence at the end is like the holy grail of artificial intelligence.
That's right.
Were they focused in smaller pieces, and how did you get to, okay, I want to go for the highest, that is general artificial intelligence? How did that happen?
Yeah, I don't know. I suspect, I mean, I'm not saying that I'm unique in that desire. I think that I'm maybe more vocal about that. And this also with cryo.
That's a good one.
When we get into that, there are a lot of people that they don't want to talk that they're interested in, being able to preserve humans, but they're working in that field. And so maybe that's the same thing in computer science, that I was just more vocal about that's what I'm interested in, the AGI. But yeah, no, so Andrew Ng was doing, autonomous helicopter control at the time,
Oh,
which, an application of reinforcement learning. We can get into all that, but you have you specify a reward function. In this case, it's maybe following a trajectory. So the error from that trajectory is a reward function, and then it's trying to learn a controller to minimize that reward function. So we were working on that. Different control of different things was what Andrew Ng was interested in at the time. So that, my advisor at Harvard, it was great. He was a new professor, and he does micro robotics, so not even really computer science, but more the mechanical side of it and the electrical side. But he had enough funding that he was sort of, whatever you want to do, you can work on. So I had a lot of freedom at Harvard, which was great. Not as much at Stanford, but I've always just been interested in that big picture, and maybe others are too, but I've been trying to be more focused on it.
and one question: was generative models, because that's the hot topic right now, something like a hot topic at that time, or it was something that was not so important, and you were working on different sides of AI, different points of different categories? Yep.
No, it just, we all build these mental maps of that we
Yep.
put knowledge and things on. For me, generative models are just like anytime you would learn basically a simulator or a model of a system, and that's what we were doing with the helicopters. We were the controller actually was fairly simple once we had a good model of the helicopter's dynamics itself, so that if you move the stick this way, it tweaks the helicopter that way. So really the big problem was learning the dynamics of the control was also hard. There were issues there too, but a major problem was learning the dynamics of the helicopter. And what you're learning when you learn dynamics is, a history, and then, or given a state you're at now, here's an input. What is a possible future that comes from that? And there are many possible futures. So you're learning this generative model. It's a generative model where, like, you can sample from possible futures of this helicopter, of what it would be doing. So yeah, and that's very, very simple similar example to sampling some random noise,
Yep.
and then, being able to generate something, but I don't know. So it all maps together in my mind of a nice little continuum of things, not some brand new technology.
Perfect. And one question regarding to that: is generative models the closest approach on AI to our reasoning mode? Do you think that's a true statement, or do you think it's just a tool that we found out that is useful?
I don't know about that. I think I'm not the best person to ask about what, how we actually reason in our heads. I've listened to some.
Let me then ask you a different way. Why generative models is the trend right now? Why did you? Because it's just the most efficient, or is just the one we understand the most? What's your idea on that?
It's a natural. Well, maybe we need to be more specific about the generative models, but what works right now is supervised learning, or we also call that, like in robotics and stuff, we'll call that imitation learning. But the idea is you get examples and you're trying to reproduce those examples. In the simplest case, it's like, here's an image, and then there's a label of it's a dog, a cat, whatever. And you're getting those individual examples. But in most real world cases, it's actually a sequence event, like a time series where you're processing things, or in language. So this starts to get us into the GPT conversations that we'll want to have. It's a series of things that, maybe not even time, but in steps, where this is the sentence these are the words of the sentence thus far, and you're trying to predict the next word. And so, so you're right. I think that's data comes in that form very readily. And then the natural way to train that and to make use of it is exactly in a generative fashion, where you're trying to say, what's the possible next word? It's almost always a distribution you have over that next word. And so you can then use that in a generative form, where you sample potential future paragraphs, conditioned on this history. So yeah, it's just a natural form. Data comes in that very well. its use, that it is useful. A lot of things, so if it's useful, money goes into it, and then it improves. Yeah. Is that good? I can keep going on things. Oh, Yago, sorry. Yeah. Can you not hear me?
Yago, you are muted, but Mark, we can hear you.
Oh, great.
Oh, okay. Can you hear me now? Sorry about that.
No
So, and how did you jump from Stanford, Harvard, and basically an academic career to start working in the industry? You mentioned before that also you were thinking in this generative intelligence and trying to find ways to fund that research. But at the end, what you start is, and please correct me if I'm wrong, is Google Brain, that is this kind of entity that is like the holy grail of the places that you can get into when you are working on AI and artificial intelligence. How do you land there? What do you find? What's the big difference between academia and AI, and industry and AI? What are the big gaps that you find?
Yeah, so I was very intentional. I did a number of these startups after the PhD, attempted them. Then I thought, okay, I'm just going to go get a research job. But of course, I didn't have, I'd now had this little gap since my PhD. So I just started reading research papers on my own. A very natural thing, and this is happening with cryonics now for me, is I just started reading the research papers and just trying out, oh no, sorry, I transitioned, right. So deep learning, that was clear that was going to be the future. So I got a job in it, like a contractor job, but it was part-time because I knew that I wanted to, and they were able to give it to me probably because of the resume that I had, even though I had no experience in neural networks. I mean, I've done a couple projects in it or something. So working on that project of theirs, this was like, they streamed sports and like American football. What they wanted to do was automatically segment out the plays in the
highlights,
and then give a quality score to those plays. So highlights, so it's processing video, and that just sounded super interesting to me. And there's no reason they should have given it to me at the time because I didn't have any experience to do it, but I was confident that I could figure it out. So I started reading a ton of research papers on that myself, then just started, trying to implement these things myself. TensorFlow had just come out. This was maybe 2016 or something, 2015.
2015, yeah.
15, 16. And so through that process, I just really reading papers were great. And this is sort of an aside, but I feel like when you hear a technique, the important things are like just understanding, so what the model architecture is, and then what the objective it's trained on is. So model architecture and the objective. And what's great is the model architecture is usually composed of a set of blocks, and they're less than 10 of those blocks. So it's just, okay, how did they piece this together for the training they were doing? Attention is a big block. That's what transformers mainly make up right now. Skip connections are kind of important. You can get depth, but so those are like 2 of the 8 of these, or maybe even 5 of these, convolutional neural networks that are convolutions. That's another of these 8. So there's aren't that many, and you kind of piece them together. So reading these papers, you get that. Another of the objectives, like what is the loss that's actually being trained on, and what is the data? So I try to understand those when I read something. I think that's a good way to read papers. But yeah, so I was reading those papers, and then an idea kind of pops in your head of like, I think that this would be a problem that needs solving, and I have an idea to solve it. And so that kind of happened to me. I reached out to, maybe in 2015, almost right away. And then I reached out to Peter Abil, who I'd worked with at Stanford, and he's at Berkeley. And then he had a grad student, Chelsea Finn, at the time, who's now a professor at Stanford. She's amazing, but she was just a grad student. And he's like, you could work with her. And I said, that's great. I just needed somebody who was experienced to be giving me some guidance on this. And so I then in my spare time was coding up, the model and doing the experiments, and I'd meet with her weekly. And then we published a paper on that. And then that led nicely into, now I felt like I could really apply to somewhere like Google Brain. the brain team. And so I applied there, and yeah, and they had so what I applied to was a residency program. It's kind of like after your PhD, you can go and work for a while, but it's like supposedly it's more competitive than actually, getting the position there, because they give you a ton of freedom, which is what I wanted at that time too. So then I did maybe 2.5 years there, very similar to academic research.
Very similar.
Brain, almost essentially the same. You don't need to apply, almost better because you're not applying for grants or anything that you might have to in academia. The funding's just there, a lot of compute resources. So, and like most professors like Chelsea now, like they have joint appointments, so they're getting paid by Google and by their university, and they get all these free resources. It's just it's a wonderful time and arrangement.
A quick question there, because I can imagine Google can have a lot of resources, and that those resources, of course, make any research really the ability to move forward pretty fast. Was this the case? Did you have resources, or were you working more like independently inside the Google? What was your experience there?
My research, and I think this might be a character flaw, I keep trying to think through it, but it was very independent, and I actually didn't leverage. Google has very unique infrastructure inside that they've developed themselves a lot of, and I didn't use any of that. I basically just used a machine with like a number of V100 GPUs on it. So I didn't use, like the TPU, the large TPU clusters they had. I didn't use a lot of the data that Google has. It was just, I think it was the nature of the research that I was doing that didn't need that, but it might be some flaw.
During this period, were you still focused on general artificial intelligence, or did you I wouldn't say transition, but let's say pivot a little bit to solve more narrow problems? Or again, general artificial intelligence is the holy grail?
Still, okay. Yeah, and this might be a good time to talk about like the GPTs and I kind of touched on it a little bit. They work really well right now. They're important. They're useful. I think that they have limitations. So this is what I talked about, the imitation learning, or just a peer supervised learning. So what I see as the problem long term is that they're trained with like an approximation of the objective that we really want them to be trying to maximize. And the objective we really want them to be maximizing is, and one can't really write it down well, but it's something about do what I want you to do, or
yes,
or maximize my, whatever I care about in here that governs my behavior. I want this assistant to have that and to, take it on and be helping me achieve the things I want to achieve in my life, which is, it can be very simple, writing this email right now or something. But these systems are trained on like a gross approximation of that. So right now they're just trained to predict the very next word. In Matt, I think I had that question about this, but yeah, so how are they trained? How is these large language models, GPT, how are they trained? Well, they take, basically the entire internet, all the text of it, they serialize it, so it's just like, one document into the next one page, but all the text just in one long thing, and they have little indicators of this is a new page and whatnot in there. So special words that mean that they're called tokens because they might not be actual words in a language. But yes, and they're just trying to predict. They're just trained, given this history, predict the next token. What's the most likely next token? So we've gotten lucky that if you train that on code, you get what is GitHub's? It's like Copilot.
Copilot, Copilot.
Yeah, you get these. What's the next character that's going to be output in the code? But it's not like, again, that's not. Well, for one thing, say you're perfect at that. There's nothing out there that's acted exactly in the way that we want an assistant to act, in this really altruistic, like learn what we care about and really act that way. Yeah, go ahead.
Let me interrupt you for a second, because you already mentioned the word assistant twice. Yeah. Why do you call these AIs assistants? Because I think here is the core of your thinking around it.
That's right. That's right. Yeah, and I mean that I don't mean it in the term of like the digital assistant like the Siri and Alexa
Mhm.
and things like that. I mean it more. Well, I think that's like yeah. So that's my
It's
view
actually
of
the
the
same.
future
Yeah.
of the AGI is that these are altruistic. So meaning they don't have goals of their own. Their only goal is really to maximize my goals or realize
Yep.
my objectives in life. And I think that that's a very pure, inherently safe because it's like an extension. Yeah, you and I talked about this, but it's like it's more an extension of you. It's kind of like it's an arm out there that and it's a third arm that cares about the exact things that you care about. And you're not necessarily aware on all of its reasoning processes, but it is you. It's it cares about your family in the way that you do. Yeah, so it's an extension in that way. And I think assistant is the right term for that. I don't
Perfect.
necessarily mean that it's like I mean that yeah, more we remain in control because we're in control of the objectives, and it's like helping us realize that realize those objectives. Yeah.
Perfect. And one question regarding these assistants is because right now, generative models is the way to go. Do you envision something different, or do you already see this is
Yes.
the main street and we're going to go with this main street? And then we're going to find, of course, in the course of the evolution of the generative models, different paths, and they will have their own names and their own specific field. But
Mhm.
do we have a clear path right now that we're going to use for most of the AI, or do you think different? And of course, in the future, it's impossible to predict. So
Yeah.
it's just a guess.
Yeah. Yeah. I think that we're going to we're going to be able to squeeze a lot more juice out of these approaches that we
Okay.
have right now, and they'll be great, but they're missing, like they're inherently missing something. You couldn't just let one of these run and, just throw a bunch more processing power at it and a bunch more data, and they'd all of a sudden be these assistants that I'm talking about. And I think that limitation is in this training setup that we're giving them examples of things that humans have created, but we don't want to create another human. We want to create this assistant that doesn't have objectives of its own. So some problems that come up, like I guess this happened with, there's a paper on this, that if you make these models like the capacity too great, you get weird things. Like if there was a bug in the code early on in the history and the model's powerful enough, then it's like, oh, I'm generating buggy code, and it'll start generating, buggy code for you in the future. And you may not be realizing it, but because you had a bug in the past, it's like, oh yeah, what it's been trained on, whenever it saw buggy code, it was going to generate buggy code into the future of that. And so then the question is, well, how do we constrain it to no, just generate good code? But the training process is inherently just this imitation training process. So
Mm-hmm.
it's very hard to do that. So reinforcement learning, so this is what like OpenAI and certainly DeepMind has really focused on. So this is, you actually have there's an objective, a reward function, some
Perfect.
value judgment, and you're trying to learn a policy under that. The problem with that approach is defining those values are in a way that doesn't cause problems, or you don't get weird behavior, unexpected behavior. It's very hard to code up that that problem. So actually ChatGPT, so then a number of us have been working on, okay, what we really want to do is learn that so not only learn the behavior, but learn that value system, that reward function.
Yep.
We want to actually learn that reward function. So ChatGPT does this, which is really cool. So it starts with the supervised learning where you've just been learning to predict the next word. And then what they did is they took another step where they generated a number of these examples, and they had humans rate them, like, oh, I like that one better than that one. And then from these ratings, and we could talk about what this loss actually is, but mathematically it ends up being very simple, but you can infer from these rankings, like I like this one better than that one, you can infer a reward function that says, such that you can then evaluate, I like this sentence better than that sentence. So from these human labeled ratings, they learn a reward function, and then they use reinforcement learning. So they pre-trained this this generative model that is predicting the next sentence, and then they're using that as like an initialization of the policy in a reinforcement learning setting where they're now using this, reward function, and they're trying to adjust this policy to, maximize that reward function. So that's kind of interesting. I don't think it's going all the way. It's definitely going in the direction that I think we need to do, where you're learning the reward function in addition to the policy, the behavior itself. Let me take a side step. Why this is good to have that reward function. So say like autonomous driving. Well, basically, it gives you some grounding if things change, like say somebody actually switched the pedals of the car or something. But all you'd had was examples of the car of a person driving a car with the pedals in the normal space. Well, all of a sudden, that policy, even though you've had thousands of, millions of examples of this, that policy is just useless. It doesn't even know how to behave. It'll swerve off the road, do whatever. But if you have this reward function that's like, placing judgments, then okay, now I can start to adjust my policy. Because the reward function says it's good to stay on the road, it's good not to hit people. Not just this encoded into your policy of when I see a person, I steer this way or whatever. But you actually have a value set, reward function. I keep using all these terms because there aren't really a good term for it, but it's another function that's learned that places judgment on situations. So ChatGPT kind of starts doing that, where you're learning that function. But again, it's like, it's not me, like when I'm chatting with this agent, it's not my reward function, it's not, my values that it's trying to maximize.
It's not your values with
It's these, random labelers who happen to say they liked this one better than the other one. So I think that the end solution, and there's Stuart Russell is another person that thinks this, we're kind of the two only people, even though he's pushed out a bunch of students, but none of them have really continued on with this, that think that that's the path forward. We need to explicitly learn what a human cares about. Stuart thinks we should learn it for a society. I disagree with that because I don't think, I have different, even within the same society, and yes, a society is like a group of values, like people shared values together. But even within that, we have varying values, and so I think that it needs to be, a learned value function for each individual. So we each have our own AI, kind of imprints on us, and it's constantly learning our reward function. Another thing that Stuart has said, which I totally agree with, it's not enough just to be learning that. You need to know that you're uncertain about it. Like what areas,
Absolutely.
like I'm uncertain about
what you don't know.
Yeah, what you don't know about that. Like I've never seen this human interact with kids, but it's not, so I'm not going to just take my best guess and run forward, really hard with it. The assistant shouldn't do that. They should know that in that space of the world, kids, I don't know what their reward function is about it. So I'm going to be really cautious about actions on that. So understanding the uncertainty about that and then learning it. I think that's the real future. I also don't I think they're super useful, but I'm not sure that, like right now we're trying to, with these large models, like when you ask it a date of something, and it's, there's a lot of examples, even this morning, who else? ChatGPT was getting in trouble because it had, it was answering some things wrong. Oh, right. It was
Google,
and it wasn't answering correctly. And it was saying, no, the year is 2022. But so we're like forcing all of the knowledge, this distributed knowledge, into a single brain. And I'm not really sure that's necessary to try to encode it. I mean, like the way humans do this is, we go, and Yago, you and I have talked about this, they know where to find that information. Oh, that's in a table, or like, chemistry, like, you may not know the molar mass of something, but that there's a table, you then go look it up, read that, actually figure out what that is. Yeah.
One additional question regarding this, because at the end we're learning about us as a society, as you mentioned before. But as a society, during most of the year the humankind has been in the planet, we thought that the sun was a god. Of course, we don't have a lot of text about that, so it's not something that should be worrying us right now. But how many mistakes are we doing as a society? That the ChatGPT, and these AIs that learn because of imitation are taking into themselves. Is that a fair point? Is that something that
totally
should
and
be?
Much of the dialogue on the internet is like, very combative and yeah, and bigoted and yeah, just not the best of us. Even not the best of the people that say it, that were actually emitting those or writing those things. So yeah, and it's learning directly from those. And Microsoft had the early, real early
Yep.
problem with the chatbots. And yeah, these are, I mean, I can't. It's frustrating because it's obvious that these problems exist. People who work in it are know that, oh yeah, you don't want to have a chat that's longer than 100 interactions or 10 interactions. But of course, the human, the marketers will put it out as this is the greatest thing. You just ask it anything. And then, the public will go in there and it'll break. And the people who created it were like, yeah, of course it's going to break on that. It's not expected, but the hype.
Actually, two questions related to that is one, for example, of the things that ChatGPT is not good at is math, because
Yes.
math has this right or wrong. It's not that you have multiple possible realities that you get next. No, it's one, just one, and that 1 + 1 is 2 in our world, and it's going to be always 2. Then we can get more complex and then go about several other fields of math. But in general, the basic math is straightforward. 1 + 1 makes 2. And we have seen also conversations where we can even trick the ChatGPT saying 1, 1, 1, 1 + 1 is 3.
Yeah.
How can we avoid, what different systems can we start, let's say, complementing ChatGPT, or maybe not at all, and that's part of the defect that it has by generation. What we can do to give ChatGPT the concept of real or valid or not valid, because there are places where you have opinion and there are places where it's a truth. And that different understanding that we all humans have, I don't think, and please correct me if I'm wrong, that ChatGPT has it right now.
Yeah, I fully agree. And right. And I think well, for one thing, right, maybe the right way to do this is to, as humans do, so give it a calculator to make use of, give it these tools that that will return the right answer. A problem with that is calculators aren't, like, these systems work because they're differentiable, which means that they're smooth. All the answers, kind of, there aren't these hard branches of decision making.
Yep.
That's the realm of really reinforcement learning with these hard branches. And when you're doing imitation, you need to have these, like, whatever the system, like whether it's following a branch in its head that you're giving it another module, they all need to be, equally differentiable in there and not have
exactly
these continuities. So it's hard to give it that. It's also hard to tell it that it should be using that, or that being right is important, because again, it's just been imitation. So the way we traditionally do this is just start giving it a lot more examples that are correct. So examples of doing math, and then maybe switch over to reinforcement learning. Like once you've pre-trained, much in the way that ChatGPT did, where maybe it has access, although you would need to pre-train it with this access, so it's kind of difficult, but it has access to tools that make it very easy to arrive at the correct answer. Iago, you and I were talking about this, and there's been a lot of research on this where it's not trying to, like, again, if you're looking at a document that has a bunch of numbers in it, like a big chart, and somebody asks you a question about that document, it's not that you just read the document and then you're ready to go, answer whatever question they have. It's like, they'll ask you a question and then you'll say, oh, you'll reference the table that's in there,
attention,
and look it up, and then read off that correct thing. Those are definitely possible, but one would need to create a large training set that's like that. That just the general internet doesn't have a lot of examples of that on it. And the more examples of that there are, then yeah, I could start focusing on. And we talked about this too. There's it's a form of attention, but it was called pointer networks was the original paper on it. But where like right now, what these models output is, right, they just output a probability distribution over all possible words that they could say next, basically. These pointer networks, they output a like a reference to something specifically. So they're not outputting a word, they're saying, like they're outputting a reference to this cell in the table. And then they're saying, you know, so somebody asks you something and they say, the answer is this cell in the table, like whatever's in that cell. And then the system can then read out that number.
Perfect.
So it's like, it's a number that's in the table. It's not just some, you know, thing that was spat out in the
Exactly.
head.
And
but creating those large training sets is really hard.
It's very, very hard. And let me do a couple of questions that also they are very oriented to these limitations that we're finding in our discovery of AI. It's okay, we have been super successful right now in create a conversational or a conversational chatbot in this case. But in case we have been failing constantly, creating an autonomous car, for example.
Yes.
Why are we finding these gaps between the different tasks? What's the base difference that in our model or in our understanding of the reality that make us successful in one task and have very poor results in the other one?
Yeah. Okay. So one aside thing, there's this theory out there that like the things that we think are hard for us because they're like new evolutionarily. So the things that we think of as easy, like balancing and like, you know, even juggling or something like that, they're incredibly difficult, but they're very old evolutionarily. So we have like real compiled programs for these things in our heads. So like we've been off, like chess was super easy to
the lizard brain, yes.
Yeah, get a good chess, you know, playing AI, you know, that was, I don't know, 40 years ago or something, 30, 40 years ago. And like, that was really surprising to us, but it's because that reasoning is like new evolutionarily and our brains are, you know, we're trying to, it's not really ground in there, good, efficient structures in our brain to be able to do that. So maybe, so I just, that was total side.
No, it makes total sense. So what you're saying is there are things that we consider easy, and driving involves a lot of these, let's say, primal brain activities, like for example, understanding if at the distance
robotic
of an
manipulation is that way in general. Like we can create a mechanical robotic hand that's, you know, very dexterous, but getting it to do that, which is really easy for us, is hard. So maybe language is part of that other one. I think another thing with driving is kind of back to our previous conversation, where there aren't good reward functions that can be applied to a variety of new situations. So I think a wrong way to create one of these driving systems would just be, you know, just try to imitate what a human's doing, because when you're presented with a new situation, you don't have anything that's guiding you in that situation. It's just like, I've never seen that, so I'm going to steer this way, or I'm going to steer this way, or whatever. And you don't have any qualitative feel of how bad it is. Like, you know, that instance, poor Tesla, but it's the one we always remember, where the, you know, truck was parked across the road and it just looked like a sign to it, you know, because it, you know, was a white truck, and it could be, you know, a billboard across the freeway up top. So the, you know, Tesla just plows right under it, and, you know, it takes off the top of the car. Right. It's not, there's no sense of like, if that is this other thing, that other thing is really bad, like, because you're going to kill your driver, and that's really bad. So you need to be cautious. So then you could use this learning of a reward function. We're starting to call that reward learning now, which I think is a much better name. It used to be called inverse reinforcement learning. But yeah, so you could take the behavior of the driver and then infer a reward function that's consistent with that. So this is probably how the driver is caring about, you know, they're slowing down because children are near. So that means something. And then hopefully the idea is that could hopefully map to novel situations to guide things. But none of that is really, to my understanding, how these systems are currently created, because the costs are so high for the company if something goes wrong. So they're actually created with little rule systems. So there'll be an intersection change thing, and somebody's like, they're first identifying, you know, here's where all the lights are and here's where all the cars, and then somebody's saying, you know, writing rules for, you're supposed to turn left if this happens, and maybe there's a parameter or two in there that are learned from the data, but it's very controlled because they want to be fairly certain that they, you know, do the right thing.
Failing the right way, even failing the right way.
Yeah. And driving is very much there. I'm more like, I take another extreme. I take a fairly driving. I think that should be the case, and you wouldn't. The way I envision this future is, I mean, you're handing over a lot when you're saying, you have complete control, and I'm assuming you're inferring correctly what reward functions in my head. I think that the way this will go is very much the way we do with children right now. Like I think it's called scaffolding in the behavioral conditioning sort of literature, where you don't let you don't put the knives on the floor, with a baby. You put it up,
Yep.
you constrain the environment such that they're doing the right things. And if they make a mistake, it's like not that big of a deal to make the mistake.
It's a safe mistake. Yep.
Yeah, it's a safe mistake. And then when you're confident that they have the values that they're going, then you're expanding that slowly and creating that. Yeah. And also, so the second thing that I think is intention really matters to me rather than outcome. Like to a big company, outcome really matters. But to me, it's like if they whacked the button that was, that like set off a nuclear war or something like that, the intention is what would matter to me. Like if they were trying to start the war or something, then that's really bad. But if it was just like an accident, I had put this button on the ground, next to this, Bayro, and accidentally whacked it, or even if it thought that was what I really wanted it to do or something, and it did it, like I'm okay with something like that. I mean, then you just need to really scaffold, make sure that it's, I think each of us will get our AIs at some age, maybe we'll be able to initialize them from their values from our parents or something. There'll be like a training period. I think it'll be like pets, where legally you are responsible for the actions of this AI. That's probably different in different countries and things. But yeah, if your pet goes out and bites somebody, you should be held responsible for it. That was your values and your training that went into it.
Mark, because we're running out of time, and it's unfortunate because I would love to keep this conversation for probably 10 hours. So,
yeah.
Where do you see right now this ChatGPT, this BERT, these models that we are using, most of them in conversational? Are you afraid of another of a big change in our lives, of the disillusionment? I don't know if that's a word, but that the people feel disenchanted for them because they at the end are not as useful as we were initially thought to be. What do you lean to? What do you think is going to start happening with this? Because right now there's a lot of fuss, a lot of FOMO, a lot of What do you see the next steps, since you have this deep knowledge about it?
Yeah. Right. So the usefulness of them, right. So I suspect, I don't know this very well, but I suspect that it'll probably follow the way other technologies do, where we will adjust our expectations of the system to like, if it's telling me something, I'm not going to fully trust that it's telling me what it is. And right now we're in everything it says is the truth, so I think people's perceptions of it will change. Unfortunately for Google, that was a big adjustment in their stock price. So I think that'll adjust. I don't know, and I think you guys are doing an exploration on this, which I think is fantastic, about how far you can push the usefulness of these. And I hopefully they will find value. I'm really concerned in the hallucinations that they do, and that the information they're providing isn't correct, and the damage that does to the company that's providing
Correct.
that. So areas that are, I think Copilot's great, like where it's like suggesting the next code you could do, because you can be looking over at it, you can use it to autocomplete, but you're still in control of it. Probably people who are writing articles, that sort of way that like it's an interactive tool that humans are using to kind of help them, but it's not giving full control to. I mean, hopefully we can get it to the point where it's trustworthy enough. I mean, it's still not the end goal that I want, but it could be useful and reliable enough that it's working.
Perfect. We will find our own limits with them, how much we can trust this. And even this morning, could be a good idea to ask about financial advisory to a chatbot, because definitely there is not something that you can trust outputting out there. So I would, that's the limitation right now. I don't think I can trust that. I cannot have I cannot trust really in the important things to these bots, these chatbots, this ChatGPT and BERT and all the other ones. Okay, so thanks again. This was amazing. We have to bring you back again to speak about cryogenics, your new passion too. I would love to in some time, because I don't want to abuse your time, to bring you back again. I will leave this 10 minutes that we have remaining for questions on the audience from the team. I don't know if you have any questions for Mark, or Juan, do you have any questions ready that we can ask Mark? Juan, I don't think we're hearing you.
I'm here. Sorry, I was just writing there that anybody who wants to ask a question, they can unmute themselves. We have a question from Facundo. Yeah, go ahead.
Yes. Hi, Mark. So basically, there is like a competition, a big competition between the big techs with Google and Microsoft. Do you think that this competition is always, I think, good for advancing the industry, right? But do you think that in this super tight competition, maybe could affect the papers and the reveal of new technology? Because maybe the transformers technology was built by Google, right? It was a paper by Google, and now it's being used by OpenAI and Microsoft to build the competition. Do you think that maybe this could affect this? I don't know, the papers and the open source community, or
the secrecy and creating more secrecy. Yeah.
Yep.
I think that there's structural reason, or at least right now, I can see these changing to be a problem. The people doing this innovation, what they care about is their reputation and the publications that they're able to make. So they would go, in theory, and from the people that I've met, they wouldn't be working at Google if they weren't allowed to publish. So if Google all of a sudden started saying, these are really important things they're doing, we're going to be keeping this secret, which they do with search. So, I mean, all of their search stuff is super secretive, but there's not that much innovation in there, and you're not going to get the best. Like if the entire industry starts closing things off, then there's a problem. But as long as there's somewhere for smart people to go where they could then publish, they're going to be choosing, like that's a high value thing in their lives. They're already taking a little bit of a pay cut to be in that world and not be just climbing up some management ladder in something else. So I think they're a constraint on that, and that they're going to want to keep publishing. So hopefully that keeps it open.
Yeah, I hope that.
we all hope the same, because what is terrible is a technology that's in very little amount of hands, because then it's completely out of the control, out of the understanding. And if we need something right now, it's understanding.
Yeah, and I hope that goes a different way. Like, I really hope we get to this individual AI where really that AI's responsibility is our value system. And then the information itself is very distributed. Maybe it's owned by individual people. It doesn't have to be compiled, like trained on a massive number of computers and compiled into a single neural network, all the information about the internet as it is right now. It could just be out there and distributed. And, oh yeah, this AI says, oh no, ask this guy. I think he knows the answer to that. And that's this guy. And yeah.
That's a beautiful way of thinking. Yep. Any more questions, Tim? More questions for Mark?
Or girl, sorry.
I had a question. Just wanted to say, thank you very much. A very interesting discussion. My question for you, Mark, is, I read somewhere regarding AI that at its current state, it cannot produce new knowledge, only leverage pre-existing knowledge. So would you agree or disagree with that?
Creativity.
Yeah. Well, I mean, no, I mean, we're like, it's able to generate the generative models. I mean, yeah, you're seeing new faces. You're able to, just describe a movie or something, and then it's generating scenes of these things. So I mean, again, the AI, like the name was created, it's overly dramatic. It's a field, and a set of techniques in that. I mean, I'm trying to do an AI, create a thing that can be created, but there's nothing out there right now. I guess ChatGPT is that. I mean, I bet if you asked it to tell you a story, I mean, that's probably a story that's never been told before. So it's maybe doing it brand new. Yeah.
One of the
yeah.
One of the big questions is about creativity. What is creativity? But that's a bigger problem, because first we have to define what creativity is, and that's more response for the philosophy. So we're getting into a very difficult area at that point. Is creativity something related to the AI or not? But we will see what happens there. But right now, definitely, they can generate things. How far they can get to this new generation, as you were mentioning, you have an AI that can generate faces. Yes, that can happen. But can an AI generate a new AI that generates new fields?
Yes.
That's the big question.
And that's actually the definition of AGI that I like to use. It's a software definition that, like, I want to get us to a point where if you put more data in and more compute, like, it would be able to reach an indefinitely capable. So its capabilities would grow. So it's not necessarily the point where it's better than all humans, but just the point where, like, all machine learning people could quit their jobs, and as long as more compute and more data were going into it, it would keep getting smarter.
And we're all done. Okay.
Well, hopefully not. Hopefully it's just maximizing what we care about and helping us. But
absolutely, yes. Let's wait for the best. Mark, we've run out of time. I'm so sorry, because there are many questions from the team. There are many questions. There are many topics related to this that are super interesting. How this will affect our lives, our jobs, our economic model. It was a pleasure to have you here. It's a pleasure to be lucky enough to be part of your knowledge. Thank you for coming to this.
No, it's my pleasure. It's really fun to talk about these. If you guys want to save all those questions, and then we could just pick up another conversation at some point.
Absolutely.
And talk about something. But yeah, it's been a real pleasure. I love talking about this stuff. I don't get to talk about it very much, surprisingly. Yeah.
Thank you very much, Mark. Have a great day. Team, thank you very much for coming, and hope you find this conversation interesting. Thank you, guys. Bye, everyone.
Thanks all.
Thank you.
Thank you.
Thank you so much.
Thank you so much.